Okay, so the first part of Unit 8 is learning about sequences. So what we're going to begin with is we need to know that a sequence is an ordered list of numbers. So this could be 1, 3, 5, 7, 2, 4, 6, 8. That's an order of numbers and it's a list of them, okay? So a sequence can be any list of numbers, but on this unit we're going to concentrate on two types. And each of these have a pattern, meaning that there's something in common of how we get to the next number. So first we need to look at the terms that we need to know. So first off, a term is one number in a list of numbers, okay? So we can have a first term, a third term, so that means that my third term is the third number in my ordered list of numbers, okay? So A1, you see this number down here, 1, is telling me, this number 1 is telling me that I'm looking for the first term in my sequence, right? So A2 is then telling me these are related. I'm looking for the second term in my sequence. Then we have A3, meaning I am looking for the third. So then if we just have A to the n, I can plug in any number for n. So if I have A to the 17, that means I'm looking for the value of my 17th term, okay? So let's go over an example. So if you guys see, we're going to look at the sequence below. We have the numbers 6, 14, 22, 30, 38, right? And that continues to go down our sequence. So the first question's asking me, what is A2? So it's telling me they want me to find the value of my second term. So we know that's going to be the second position. So 6 is in my first position, 14 is in my second position. That's the number I'm looking for, so my answer would be 14. So then they also are asking, what is A8? So they're looking for what is the value of the 8th term. So I'm going to count to find what number is in my 8th position. So 1, 2, 3, 4, 5, 6, 7, 8. Meaning the value is going to be 62. So the value of my 8th term is 62. All right, now that we've gone over two examples, I want you guys to try to figure out what you think A5 is equal to. Okay, so at this point, you guys should know that A5 should have been equal to 1, 2, 3, 4, 5. It would have been equal to 38. Okay, but there are other ways that they can ask us these questions. They're saying AN is equal to 30. So now they're giving me the value of the term, and they want me to figure out what is that term. What position in my number line is that in? So I see 30 here, and I can count 1, 2, 3, 4. That means my N would be equal to 4. Because it is the fourth term. 30 is the fourth term in my sequence, okay? So now that I've given an example of that, why don't you guys try number 5 and figure out what term is equal to 70. Okay, you guys should have gotten that the 10th term is equal to 78 because 78 was in the 10th position in my number line, okay? All right, so let's kind of look at this. What is this pattern telling us? Did we notice anything about our sequence above? Was there a pattern to the numbers? Okay, so do you guys think there was a pattern? Go ahead and answer yes or no. So yes, I actually did see a pattern, and I hope that you guys did too. So we're going to figure out what was that pattern. So our sequence is an example of the first special type of sequence that we're going to use. So the name of this one that we're first going to get into is an arithmetic sequence. So in order for something to be an arithmetic sequence, it needs to be a list of numbers where you add or subtract the same number every step. Okay, so look back at our sequence. What number do you think we're adding or subtracting to get to the next number in our ordered pair in our example above? Okay, you guys should have seen that we were going up by 8 each time, right? 6 plus 8 gets me to 14, 14 plus 8 gets me to 22, and so on, okay? So it is arithmetic because we're going up by 8 or the same number every single time in our sequence. So now that we know that, there's actually a formula we can use that will help us simplify the process. So if something is an arithmetic sequence, we can use the formula a to the n equal to a sub 1 plus n minus 1 times d, okay? So again, where a to the n is the value of our 9th term, a to the 1 is our first term, so the first number in our sequence, and d is the common difference, so the number that we add or subtract each time. So first we're going to figure out how do you find the common difference. So in order to find a common difference, it's always your second term minus your first term, okay? So in this case, we're still using our example from above. So my second term was 14, my first term was 6. So what is 14 minus 6? 8. So my D, or my common difference, is going to be 8. All right, why don't you guys go ahead and figure out what would be our first term? What is A1? Okay, you guys should have seen in our sequence that our first term was 6, because it is the first number within our sequence. Okay? All right, so let's move on to actually implementing this formula. So you guys will be able to use this formula on any test going forward, so don't feel like you need to memorize the formula, but you do need to understand what each part of the formula means, right? So question 6 is asking me, what is A16? So it's saying, what is the value of the 16th term? So I'm just going to plug in, I know I'm looking for A to the 16. Excuse my handwriting. And now we're going to plug in A1. I know that my A1 is equal to 6. So I'm going to plug in a 6 there. Plus, what is my N? N, you will see, is always what's next to the A, right? So in this case, what's next to my A is 16. So my N is going to be 16. That number next to your A is telling you what term value you are looking for, right? So that is always going to be your N. Minus 1, and then we solved that D was equal to 8, right? So now all we need to do is plug this in our calculator and solve for what is the value of the 16th term. Okay, so I've gone ahead and actually writ out the steps mathematically because it does take me a while on this so you guys can see it. So I first subtracted 1 from 6 because we're following PEMDAS, 1 from 16, that gives me 15. I then multiplied because my next order in PEMDAS would be multiplication. So 15 times 8 got me to 120, and then I added. So the value of my 16th term is 126. Okay, let's also do number 7, and then I'm going to have you guys do number 8 on your own. So again, instead of looking for the value of the 16th term, we're now looking for the value of the 32nd term. So we're still going to do the same thing. I have A to the 32 is equal to, my A1 is still going to be 6 because A1 is going to stay the same because we're using the same pattern. But in this case, instead of my N being 16, it's now 32, right? Because that is the number that's next to my A. So 32 minus 1, and then we're going to multiply that by our common difference, which stays the same, which is 8. Okay, so again, I've gone ahead and I wrote out the steps mathematically. So first we subtract 31 from 32, giving me 31. 31 times 8 then gives me 248, and 248 plus 6 gives me 254. So the value of my 32nd term would be equal to 254. All right, why don't you guys try to do number 8 and tell me what answer you get. Okay, so you guys should have gotten that our 103rd term would be equal to 822. I went ahead and wrote out the steps for you so you guys are able to check your work. Okay, so now we are going to be moving on to the second page of our notes, okay? So we're still using the same ordered line, right? It says how far along in the sequence until we reach the number 150. So this is another way of asking a question. Instead of giving you the term, and they want you to find the value, they're giving you the value and they want you to find the term. So they're giving us AN and we are looking for N. So A1 staying the same, right? Because we're going to always have the same first term, which is 6, and D always stays the same too. So our common difference is going to stay 8. Those two things are not going to change. In our previous examples, they gave us N, but now they are giving us AN. They are giving us the value. So we now have 150 for my AN. So what I need to do then is plug in what I know into my formula and solve for what I don't know. So I know that my total AN is equal to 150. So I'm going to set 150 where my AN would go in the formula. That's going to be equal to my first term, which is 6, plus N. Do we know N? Do we know what term is equal to 150? No. So that is what we are solving for. But we still do know D, so we would plug that in. All right, so what we need to do is then isolate the one variable we don't know, right? So we all know the distribution rule. We know that this 8 needs to go to both my N and both to my 1. So that step would look like 6 plus 8N minus 8, okay? So we're just going to combine like terms, right? So 6 and negative 8 is going to give me 6 minus 8 gives me negative 2. So now I know that 150, again, excuse my handwriting, is equal to 8 n minus 2. All right, you guys all should be able to solve a equation like this. So I'm going to go ahead and ask you guys to solve for n and make sure you're understanding how to do it. Okay, you guys should have gotten that the 19th term is equal to 150. So I went ahead and I showed my work. I added 2 first, and then I divided by 8, and that got me an n of 19. Okay, I really want you guys to try to do number 10. It's just like number 9. Go ahead and work it out and tell me what answer you get. Okay, you guys should have gotten that the 57th term is equal to 454. So 57 should have been your value for n. Again, I plugged in what I knew. I knew that they gave me an of 454, and then a1 as 6, and my d is 8. If you were to solve through the problem, you would have gotten n by itself, which you got to 57. Okay, so that's our overview of arithmetic sequences. Now we're going to look at another type of sequence. So look at this sequence. We're now using the numbers 3, 6, 12, 24, 48, 96. So do we think this is arithmetic? Go ahead and tell me if you think it's arithmetic or not. Okay, you guys should have said no, because in order for a sequence to be arithmetic, we need to add or subtract to get to the next number in the order, and this is not the case here. Because to get from 3 to 6, I'm adding 3. But to get from 6 to 12, I'm adding 6. So we do not have a consistent number that we're adding or subtracting each time. Okay, so if we're not adding or subtracting, we could possibly be multiplying. So that's when you have a common ratio. If you are multiplying, you have a common ratio, meaning you are multiplying by the same number each time to get to the next number in your sequence, okay? So in order to solve for a common ratio, you can do any term divided by the previous term. I kind of like to always stick with my second term divided by my first term, okay? Just so we can keep it simple, we're always going to say our second term divided by our first term. All right, so let's see if this does have a common ratio. So what we need to make sure is that my second term divided by my first term is equal to my third term divided by my second term. So we know that my second term was 6, because that's the second number in the sequence, right? And my first term was 3, because that's the first number in the sequence. And that would have been equal to 2, right? Next, we have 12, which is the third number in my sequence, divided by 6. That is equal to 2. And why don't you guys go ahead and tell me what I would be plugging in for my fourth term, and then we can see if we have a common ratio occurring. Okay, so you guys should have seen that we would have been plugging in 24 for our fourth term, and 24 divided by 12 also gives me 2, meaning since it's 2 every single time, my common ratio, or my R, is then going to be equal to 2. So that's how we solve to see if something is geometric, and that's also how we solve for our ratio. All right? So if anything has a common ratio, that means that is a geometric sequence. So a list of numbers where you multiply every step, okay? When you have a geometric sequence, we're using a different formula. This formula is going to be an is equal to a1 times r raised to your n minus 1. So that raised means we're raising r to an exponent, okay? So again, an is your nth term, a1 is your first term, and r is now your common ratio, so the number that you are multiplying each time. So let's plug in what we know to our formulas, right? So it's saying a15. They're asking for what is the value of my 15th term, right? So what am I going to be plugging in for a1? The first term, or the value of my first term was 3, so that's always going to be my a1. My r is always going to be 2, right? Because we know that we were multiplying by 2 each time to get to our next step. So what's going to be my n? N is what is next to my a, the term value they're asking for. So my n here is going to be 15, and then I'll just do minus 1. All right, we're always going to go in order here, right? Before I do anything, I'm going to subtract 1 from 15, leaving me with 3 times 2 raised to the 14th. When we're following our rules of PEMDAS, we know that we always do exponents before we do any multiplication, all right? So we need to figure out, you guys are going to want to use a calculator here, what is the value of 2 raised to the 14th? Okay, you guys should have gotten in your calculator that 2 pardon my 3 there, is equal to 16 384. All right, so I'm just using a calculator there. Next step is I'm just going to multiply that by 3. So then we know that my 15th term is going to be equal to 49,152. All right, so there again, we're just plugging in what we know. So what I want you guys to do for number 12 is pick the correct format of our formula, okay? All right, you guys should have picked the formula that said 3 times 2 raised to the 21 minus 1. So now all we need to do is solve this, all right? Okay, so once I solved it all out, I first raised 2 to the 20th, which gave me my very large number there, and then I multiplied that by 3, so my answer would be 3,145,728. Okay, so I want you guys to work through number 13 all on your own, and then you guys will be done with today's notes. Okay, so you should have gotten that the value of our 18 term was 393,216. Okay, so again, don't be alarmed when your geometric numbers are very large. When you're dealing with exponents, they are going to grow very large very fast. All right, so that was the first day of our notes for Unit 8. Now you guys can go ahead and use these notes to work through your practice problems.